Hi, welcome to Lesson 8 of the IB Physics syllabus at Edu Solutions Institute. So today's lesson, we'll be looking at linear momentum. Now, linear momentum is based on the effect of objects in motion. Now, the linear part comes in because these objects are moving in just one single plane. So if it's going in the x plane, horizontal, it only maintains a horizontal motion. If it's going in vertical plane, the y plane, it goes in the vertical plane only. So therefore, objects moving will actually have what we call momentum. If you're not moving, then your momentum is zero. So in order for you to have momentum, you have to be moving. The more you move, the more your momentum is. Right? Now, the equation for momentum is that P is equal to mass times velocity. Now, the P represents momentum, mass is m, and v is velocity. Now, it's good to know because velocity is a vector quantity that regards direction, then momentum also is a vector quantity. And that means if an object is going to the right, then it will have a positive momentum because the velocity is positive. Then it's going to the left, then the object's velocity is negative, so hence it will have a negative momentum. If it's going up, then its momentum is positive because the velocity is positive up. Going down, the velocity is negative, so its momentum is also negative. So therefore, momentum is based on the velocity direction. So the unit that we represent momentum with is that mass is measured in kilograms and velocity in meters per second. Or in some cases, you're going to see that the unit is also Newton seconds. Right, so both units are used, but this one is your SI unit. And dealing with momentum, we look at a term called impulse, which is represented by the capital G. An impulse is basically just a change in momentum. That means if we're going at this speed and we change our speed, then we change our momentum. And how do we change the speed? Is that the force applied onto the object will change. So if we're speeding up, the force gets bigger. If we're slowing down, then the force gets smaller. So therefore, because there is a change in force, then that means we get a change in momentum because the speed is going to change. And if the speed changes, then that means we have impulse. Right? So therefore, impulse is generated by two equations. J is equal to F times C, or J is equal to M, V minus U, where V represents the final velocity. Right? Because the velocity is changing, it's going to move from initial, which is U, to final, which is V. Right? So therefore, because these two equations are both for momentum, we can equate these two equations and we get that F times C is equal to mass times V minus U. Right? So that's the principle on which impulse works. So in order for you to have impulse, you have to have a net force. If there is no net force, then your impulse will be zero. If there is no force, zero impulse. Right? Once you are moving, then if you change velocity, then we're changing momentum, which means we have an impulse. Now, what's the importance of impulse or momentum? Let's consider a tennis ball hitting a rocket. Right? So when the tennis ball approaches the rocket, right, then the rocket applies a force. A force that it applies will cause the ball to change direction, and change of direction means velocity is changing, right? Because now it's changing direction, means it applies an impulse to the ball. Now the ball now will move with that impulse, which will be determined by the force that it has, which is generated from the rocket. So therefore, impulse is important because it tells us how force is acting as well as the duration of the force. Because if we have impact for a longer time, right, as compared to impact for a shorter time, then it tells us about the impulse. So for a longer contact time between the ball and the racket, then the impulse is large. For a short contact, meaning the ball hits, bounce off immediately, then the impulse gets smaller. Right? So the contact time is also important. It's also important because we can find the force. So the force would be equal to the impulse over time. If there's a small contact time, then that means the force is great. And then the principle of using this would be, let's say someone is falling onto ice from a little hat, a great hat, right? If they're falling on solid ice, then that means the contact time with the ice will be very small. And in that case, will cause to generate a very big force. Now, if you go to dropping into a more looser ice form, snow, right, where the contact time is going to be greater because the person will be sinking in that ice, then that means the contact time is great, so that means the force that's generated would be smaller. And hence, someone falling into a looser surface will experience a smaller force, which would cause them to get less hurt or less harm from a person dropping onto a more solid surface, where the contact time for that impact will be short, hence will generate a greater force to cause greater harm. Now, the final thing to talk about linear momentum or impulse is that we always have what we call a force time graph. Right? So when a force is acting on an object that's in contact with, then we can generate a force time graph. Right? Force on our y-axis, time is on our x-axis. Now in this case, it shows that we can use the rocket and the ball, for example. At this point is where the ball is just touching the racket. Right? Over a period of time, the racket will generate a great force onto the ball, reach a maximum force, and then this is where the ball is changing direction to really come off the racket. So therefore, the force that the ball is feeling is getting less and less until it leaves the racket at that point. So therefore, we get a force time graph of that situation. Now, the reason why we look at the force time graph is because the area of this shape that it produces gives us the impulse. So once we calculate the area of this shape, it will give us the impulse of the object. So in this case, it will be of the ball being hit by the racket. Alright, so from this force times graph, we always can get the impulse. We also can get what's the maximum force that a racket produces onto the ball, and we can get the time of contact between the racket and the ball. Alright, so this is where we end our linear momentum. I hope that you understand and you learned something new today. So thank you for watching, and I'll see you next week where we continue to learn about the IB physics syllabus. Thank you.